Hello.
Assalamu alaikum, sir.
Walaikum assalam. Oh, sorry, I got late.
No problem.
Walaikum assalam. So, any doubt from the last class?
No, sir.
Salman, any doubt?
No, sir.
Okay. So, we have discussed all different problems related to how to solve instantaneous nature or instantaneous velocity, instantaneous acceleration, average velocity, and so on. Today, I will teach you something more interesting related to that particular calculus. Suppose if you have velocity is equals to 2t plus 5. And if you have to calculate, find displacement for t is equals to 0 to t is equals to 4 seconds. And also acceleration at t is equals to 2 seconds. So from the same function, we have to calculate two different terms. So how to start with? We have velocity is equals to 2t plus 5. As we have discussed in the last class, velocity is nothing but dx over dt. Okay, so it should be equals to 2t plus 5. We have to derive this particular dx. So bring this particular dt to the right side. It will be dx is equals to 2t plus 5 multiplied by dt. Now open this particular bracket. So it will be 2t dt plus 5 times dt is equals to dx. Dx is a small segment or a small displacement, and we have to derive the whole part. So what we do is, so we can simply integrate this particular function like this. And what is the limit to integrate? From 0 to 4 seconds. So put time 0 to 4 and 0 to 4. I think we have discussed integration in our earlier classes. Now you would be able to derive this particular relation. Okay,
Yes, sir.
Khalid.
Yes, sir.
Okay, just try to solve this particular section and try to obtain x part. For integration, we have formula if x to the power n dx, it should be equals to just increase the exponential by 1 and divide by n plus 1. So in this section, we can write x raised to the power 0 and t raised to the power 0 as a function dependent with x and dependent with time. Any doubt while solving this particular section to any of you? First, try to integrate this particular section using this formula and then put the limit as given. Hamza, check your result. Khalid, your answer is correct. Hiba, any doubt?
No, sir.
Salman, are you doing?
Yes, sir, I'm doing.
Okay. Khalid, do the second part. Find acceleration at t is equals to 2 seconds.
Okay, sir.
Now it's correct. Hamza. Try to do second part. For velocity, it was nothing but differentiation of displacement. For acceleration, it was differentiation of velocity with respect to time if velocity is time-dependent function. But if velocity is displacement-dependent function, it would be dv over dx times p. In this question, here velocity is time-dependent function. Just apply this particular relation to find acceleration. Tell me the integral part of this particular part. Tell me the answer. Here we have x raised to the power 0. So on integrating by this way, it will be nothing but x raised to the power 1. Good. Salman, 2 is coefficient here. T raised to the power 1. So on integrating, it will become t square over 2 plus 5. And integration of t raised to the power 0 is nothing but t. Here 2 and 2 gets cancelled out. Put the limit from 4 to 0. So it would be nothing but square root of 4 is 16 plus 5 times 4 is 20. And 16 plus 20 is nothing but 36 meter. Saman, have you get the same answer? Okay, try to do the second part. Find acceleration. Okay, try the second part. Khalid, have you solved?
Yes, sir.
Tell me your answer.
18 meter per second square.
18 meter per second square. Okay. Hamza,
Yes, sir, done.
answer.
So 18 meter per second. square.
you have all solved? What you have done for this particular function?
So 36 by 2. Taken 36 by 2.
Oh, what was 36 in this particular previous part? It was
Velocity.
just x. We have calculated x. And x is nothing but?
Displacement.
Good. So you are just solving displacement upon time. And we have to calculate acceleration.
No, sir, I didn't do that. I
So
found the derivative. Derivative I got 18 meter per second.
we have to check whether this particular function is time dependent function or not. If it is time dependent function, just use calculus method to obtain the required part. For acceleration, we have a relation which is dv over dt. It means just differentiate that particular velocity with respect to time. So just differentiate dv over dt. 2 being coefficient, we have t raised to the power nothing but 1. On differentiating any function, it will be like nx n minus 1. Hiba, what is the exponential of t here?
0.
It is just 1. Okay.
Oh, yes,
So
sir.
on solving by this way, it would be nothing but 1 e 1 minus 0, 1 minus 1. Is it clear?
Yes, sir.
And tell me the differentiation of any constant part.
0.
Good. So now what we left with? Just 2. As t raised to the power 0 becomes 1. So this is nothing but acceleration, and it will comes out to be just 2 meter per second squared. Whether this particular term is time dependent function or not, Hamza,
Yes, sir.
whether this particular term is time dependent function or not,
Yes, sir.
where it is time in this particular part, it is just 2. There is no time dependency in this particular part. So we called it as constant, as 2 is independent of time here. Okay.
Okay, sir.
So some may ask you, tell me the nature of the acceleration for this particular function. So we call it as it is constantly accelerating motion. Okay.
Yes, sir.
Khalid, any doubt?
No, sir.
How you have got the 18 meter per second?
I think I did a mistake
Where? While differentiating.
in the. Yes, sir.
Okay. Salman, any doubt? Just write this. I'm giving you one problem to solve. Here x is displacement and t is time. We have to calculate initial velocity, then next velocity at t is equal to 2 seconds and acceleration at t is equal to 2 seconds. Okay, just 1 minute. Since this particular differentiation is just a constant number, which is just a 2, there is no time in this particular expression. So this particular expression would not change with respect to time. So we called it as a constant value. So acceleration is nothing but a constant. So we call it as a constant accelerated motion. Is it clear?
Yes, sir.
Okay, just try to solve the second one. First, take the differentiation. It will give you velocity. First, obtain that part.
So do we have to find the velocity also at 2 seconds?
Yeah,
Okay.
initial velocity as well as velocity at 2 seconds, both. Hiba, can you tell me what do you mean by initial velocity? Khalid, do you have any idea about it?
Sir, first we'll like rearrange the variables
Yeah,
and then we can do differentiation of, no, sorry, integration of all that.
we have displacement. We have to differentiate this particular part, and the differentiation of displacement will gives you velocity. Okay, so just differentiate this particular part, whatever the way you want to. Okay, whether on rearranging or as it is. I have just asked you, what do you mean by this particular initial velocity? As we have discussed in uniformly accelerated motion, the velocity of a body when it just started the motion is called initial velocity. It means the time for that particular motion to be started was just 0 second. Is it clear?
Yes.
So
Yes.
whenever a question asks you to find the initial term, just put the particular expression time to be 0. It will give you the velocity at the starting point, which is called initial velocity. So first part, just differentiate this particular function. You would obtain v, put t is equals to 0. In this particular expression, it will call as initial velocity. Any doubt related to finding initial velocity? Hamza?
No, sir.
Okay. Just try not to make any mistake while differentiating. Have you all differentiated this particular function? Or should I help you?
Sir, answer 0.
Yes,
Velocity is 0.
at t is equals to 0 or at t is equals to 2 seconds.
T is equal to 2 seconds.
No, it won't be 0. Just check your calculation. Just 1 minute. Hamza, whether it is initial velocity or velocity at t is equals to 2 seconds.
Sir, velocity at 2 seconds.
Let me check. Good. You're correct. Khalid, send me your answer. Just check your calculation. Iba, have you done the differentiation part?
Yes, sir.
Tell me your answer. The differentiation of 5 would be
0.
good. 2 being coefficient, take it outside. And t raised to the power nothing but the
1.
exponential of t. Good. So it will becomes 1 t 1 minus 1 minus. Here we have exponential of t would be.
3.
So it will be 3t 3 minus 1. So on rearranging, it will be 2 minus 3 times t square. Okay.
Yes, sir.
So first we have to calculate velocity initial. So what we'll do for initial velocity, just put time to be 0. So this will give you initial velocity. So what would be? It will be 2 minus 3 times 0 squared. And 0 multiplied with any number would be 0. So we're left with nothing but 2 meters per second. Is it clear to everyone?
Yes, sir.
Okay. Just put t is equals to 2 seconds in this particular expression to find the velocity at t is equals to 2 seconds. Khalid, have you got the same expression for velocity? Salman, is it the same expression what you got? Good. Just put the value of t to be 2 meters 2 seconds to find velocity at 2 seconds. In this expression, just put the value of t to be 2 seconds to find velocity. Good, Hima. Your answer is right. Khalid, any doubt?
No, sir.
Do you got the same expression for velocity on differentiating?
Yes, sir.
Okay, just put the value of t to be 2 seconds to find velocity at 2 seconds. Salman, send me your answer. We have 2 minus 3 times t is nothing but 2 squared. So it will be 2 minus square of 2 is 4. 4 3s are 12. It will be 12 minus 2 minus of 10 meter per second. Just try to find the acceleration. Khalid, let me check, please. 1 minute. Good. Hiba, have you calculated acceleration?
No, sir.
Any doubt? We have expression for velocity. V is equals to 2 minus 3 times t squared. So what we will do for this particular expression to find acceleration? Hiba,
Differentiation.
yes, just differentiate this. So dv by dt. First is 2. 2 is constant term. So differentiation would be Hiba. Differentiation of 2 would be
0.
okay minus 3 being coefficient. We have t squared. So how to differentiate it? 2
2t.
t to the power 2 minus 1. So it will become 3 into 2 just minus of 60. So from this, acceleration is nothing but minus of 60. Whether this acceleration is constant or time dependent function. Hamza,
So time dependent.
good. So just put the value of t to be 2 seconds in this particular expression and then acceleration being calculated. Salman, on putting t is equals to 2, it would be nothing but minus 6 into 2 becomes minus of 12 meter per second squared. So what can you conclude about this particular acceleration? Since it is in negative, so we can say it is a retarded motion or decelerated motion. Okay,
Yes, sir.
okay. Any doubt to any of you?
No, sir.
No, sir.
Hiba?
No, sir.
Okay. Have you written?
Yes, sir.
Salman? Okay. So we have done how to solve these type of problem. The next is using calculus method, we have to derive equation of motion as we have used in uniformly accelerated motion. You must have learned in your class 10th, 9th, I think, to derive equation of motion using graphical method or using algebraic method. But in this class, we have to derive that particular equation of motion using calculus method. So the next is derive equation of motion using calculus method. First equation is V is equals to U plus AT. I have called this particular equation as velocity time relation. So how to derive this particular relation? Just this is velocity time relation. Using velocity and time, we would be able to calculate acceleration. So first, let's take acceleration is equals to dv over dt. Okay. Now rearrange this part to find dv to one side and move this dt to the other side. So it will becomes a times dt is equals to dv. Okay. Now we have to put limit for this particular calculation. So for the limit, now at time t is equals to 0, velocity of the body would be u. Similarly, at some later time t, velocity becomes v. So on integrating this particular function, at time t is equals to 0, its velocity would be u, and at time t is equals to t, velocity will becomes v. This is how we define the limit of a particular function. Is it clear to everyone?
Yes, sir.
Hiba, any doubt?
No, sir.
Okay. So we have a being constant, taking it as coefficient. We have dt, the integration of dt with nothing but t, or you can simply put t raised to the power 0 here and integrate that particular part. So it will be 0 plus 1 divided by 0 plus 1. This whole part will give you nothing but t itself. Okay. So instead of writing this to multiple times, just try to define this particular term on integrating will give you the whole part, that is t. Here limit is nothing but 0 to t is equals to. Similarly, we have dv. So on integrating, it will gives you v. Just put limit from 0 to v. Is it clear?
Yes, sir.
Yes, sir.
So it will be a t raised to the power, it will becomes t, upper limit, lower limit, v, upper limit, lower limit. Now put their limit. So we have a, upper limit of this particular t would be t, and it have exponential 1. So it will be just 1, minus lower limit is nothing but 0. So I have just placed the value of this particular t to be this in place of this. Similarly, for the right hand side, for the place of this particular v, just put upper limit v and lower limit u and make difference over that. On rearranging, it will be a times t, and this will be negative. Put it to left side, it will becomes u plus at is equals to. This is how we define first equation motion or derive using calculus method. Is it clear to everyone?
Yes, sir.
Yes, sir.
Okay, just write it. Salman, any doubt?
Sir, done.
Okay. Hiba, have you written?
Yes, sir.
Hamza?
Yes, sir. Written.
Okay, good. The next equation of motion is S is equals to ut plus half at square. S is displacement and t is time. So we call this particular relation as displacement time relation. So using this particular displacement time, you can define velocity. So the first step is let velocity is equals to dx over dt. Okay, so we have to rearrange this particular part to find dx. So this particular denominator move on to left side, so it will becomes dx is equals to v times dt. Is it clear?
Yes, sir.
Now we have to substitute this particular value of v from first equation of motion, as we have v is equals to u plus a times t. Why I have substituted this particular value? As in this particular equation or this particular expression, there is no any term regarding v. So we have to substitute this particular v in terms of this particular part in this expression. So it will be u plus a times t multiplied by dt, which on expanding becomes u times dt plus a times t dt is equals to dx. Is it clear?
Yes, sir.
Now, just take limit for rearranging this. At time t is equals to 0, the initial displacement of this particular body would be 0. Now, at some later time t, displacement would become s. So just integrate this particular function and put this particular limit and try to obtain the result. So we have dx is equals to u times dt plus a times p dt on integration limit t 0 to t, 0 to t, and displacement from 0 to s. So just integrate this particular part, put their limit, and try to simplify this. You will definitely get this particular result. Okay, Anzam?
Yes, sir.
Okay, try to solve. Salman, it should be t square over 2 and the coefficient of a. Khalid, just integrate properly. Hiba, tell me your answer. Here we have dx. The integration of dx would be x limit from 0 to s. Now u integration of dt would be nothing but Hiba,
T.
good, and limit upper limit minus lower limit plus a. We have exponential of this particular t here is 1. So how to integrate that? It will be 1 plus 1 divided by 1 plus 1. Okay,
Yes, sir.
with limit from 0 to t. Now, on rearranging, it will be ut upper limit, lower limit plus t squared over 2. So we can write it as half a to be outside and just t squared with limit from 0 to t. Now put their limit. So upper limit of x is s, lower limit of x is 0, upper limit of t is t and lower limit is 0 plus half a upper limit of t square minus 0 square. So we're left with s is equals to ut plus half a t square. Any doubt? Hamza?
No, sir.
No, sir.
Saman, any doubt in this calculation? Have you all written?
Yes, sir.
Yes, sir. We have finished before.
Okay. Hiba? Okay.
Yes, sir.
Third part is b squared is equals to u squared plus 2 times of a into s. This is just velocity displacement relation. So how to deal with this? For defining relation between velocity and displacement, just take acceleration is equals to dv over dt. But in this particular expression, acceleration is related with velocity and time. We had to convert this particular time in terms of displacement. So just multiply and divide by dx. So it will becomes a is equals to dv over dt times dx over dx. Now on rearranging, bring this particular to this part and this to this part. So it will becomes dx over dt times dv over dx. So it will be nothing but velocity v times dv over dx is equals to a. Now this expression has only velocity and displacement related with acceleration. This is the same expression as we are using in velocity x-dependent function if velocity was for calculating acceleration. Now, bring this dx to the left-hand side. Now it will becomes a times dx is equals to v times dv. Now take the limit. For displacement 0, velocity of this particular body would be u. Now for displacement s, velocity of body becomes v. For this limit in the above expression, it will becomes a times of dx integration is equals to v times dv integration. At 0 displacement or a starting point, velocity of body was u. At some displacement s, some later time, it becomes v. Just integrate this expression, put their limit, and try to obtain the expression. Okay?
Yes, sir.
Okay, just try.
Sir, done.
Okay. You got the same result? Khalid,
Yes, sir. Same result.
good. Good, Salman. Hamza, in doubt?
No, sir, almost done.
Hiba?
No, sir.
Okay.
Sir, done.
Got the same result? Hamza?
Yes, sir.
Okay. Hiba, have we finished?
Yes, sir.
Got the same result?
Yes, sir.
Good. So we have done this particular part, which is calculus-based problem or non-uniformly accelerated motion. The next part or the important part of this particular chapter is graph. In graph, we deal with just two different parameters. First is slope and the second one is area related to that particular curve. So in any of the graph, first try to define whether this particular graph is applicable for the given quantity or not. First check this. First, be sure whether the graph is valid or not. How to define whether the graph is valid or not? I'm giving certain tips. First, time and all scalar quantity can never be negative. So first check whether the expression or the graphical representation of the quantity is in scalar form or is in vector form. So scalar form quantities can never be negative. So scalar quantity can never be negative. It means if you have a graph related to distance versus time, and the slope of that particular graph is going negative. So the slope of distance time graph will give you speed, and speed can never be negative. So the graph won't exist. Okay. Similarly, time can never be negative. So if the coordinate of a point, suppose this is your time and this is your displacement, and if a curve is going like this way, whether this particular curve is possible or not, you say no. Time from this point to this point is showing in this particular curve is negative, but time is a scalar quantity which can never be negative. So this graph is not valid. Okay. The next part is a single particle can't exist at different position at the same instant of time. A particle exists at just one instant at one given point of time. A body can exist only at single point at given instant. Suppose if a graph is given like this, this is your position versus time. Whether the graph is possible or not, just draw a vertical line for this particular curve. Let's say this. What it's just depicting, it is saying this particular particle has two different positions, one at this position and the other as this position at same given instant of time. Whether it will be possible or not, Hamza? Whether a particle
No,
can
sir.
exist at two different positions at the same instant of time?
No, sir.
No, it can't
No,
be
sir.
possible. So these are the basic three tips regarding any curve, whether the curve would exist or not. So just try first to check whether the curve related to the given quantity is possible or not. Then later on, we'll define the slope area related to that particular curve. Okay.
Excuse me, sir. Can you explain the first graph again?
Okay. Just check whether the graph is valid or not. Okay. Valid or not means or depends upon these particular terms, whether the quantity given in this particular expression is scalar or vector, or whether the slope of this particular graph defines you scalar quantity or vector quantity. Suppose in the same expression, if I ask you to find the slope of this particular graph, and let's say x is displacement here. So if you want to calculate slope at this particular given instant of time, so just draw a tangent over this particular point. Tangent will define your slope at the given instant. So if I draw a horizontal line over this, the inclination of this particular line for this instant would be negative or positive? Negative. And this is your distance and this is your time. The slope of distance time graph will give you speed, which can never be negative. So this particular graph will also not be possible. So first check whether the graph is valid or not, depending upon calculating the slope or calculating area, or what quantity of this particular curve or this particular relation is giving you, whether they are scalar or whether they are vector, whether they are valid for this given condition or not. Just try to check first. Okay.
Yes, sir.
Okay. Next is we have certain formula to calculate different relationship. Suppose if you have a circle or any of the curve like this, and you have to calculate the area related to this particular circle. So how you define it? Just draw a vertical from this point. Just draw a vertical line from this point. So this will tell you some x1 point This will tell you some x2 point. Similarly, just draw a horizontal line from here. This will be your y1, and a horizontal line from here. This will be your y2. Since this particular curve would be a circle, would be an ellipse, or any of the geometrical figure, it is curve. So the area of these type of curve would be nothing but pi times of r1 into r2. If instead just a circle, use just pi r1 into r2. We can't say pi r square. If you use pi r square, it means you are using just one coordinate at a time, whether you are using just x coordinate or whether you are using just y coordinate. So you can partially with any of the other coordinate. Okay. So it will be better to take both radius to calculate the area of that particular given curve. So it will becomes pi. This particular end coordinate will define the diameter of this particular curve. So we just x2 minus x1 divided by 2 will give you radius and the given curve. Similarly, y2 minus y1 divided by 2 gives you the radius of the other coordinate. By this way, you would be able to calculate the area of the any curve. Is it clear to everyone?
Yes, sir.
Yes, sir.
Yes, sir.
Good. Next is, do you know the formula for calculation of trapezium? Area of trapezium?
Sir, half b into h.
Half into
Yes, sir.
sum of parallel sides
Height.
into separation between them. Trapezium is like this. If you have a parallel line like this, and there is perpendicular separation in between them. So this is your A, and this is your B. These are two parallel lines, or suppose two y coordinate, and this is the perpendicular separation between them, which is called H. So area of this particular geometrical figure is half sum of parallel sides into perpendicular separation between them.
Sir, done.
Okay. Hamza written.
Yes, sir.
Salman. Okay. Hiba. Done.
Yes, sir.
Okay. Next is, if you have given some equation regarding any of the quantity, whether displacement, velocity, acceleration, how to define whether this particular equation represents straight line or parabolic curve, hyperbolic curve, ellipse, or any other thing. I'm giving you some certain tips regarding equation and their graphs. First, if y is equals to any constant, it will give or it will represent a straight line passing through that particular coordinate, but opposite to x-axis. So it will represent a line parallel to x-axis and passing through that coordinate. Suppose if y is equals to just 2, so what it will define on the basis of graph. So this is your x-axis, this is your y-axis. So it will represent a line passing through 2 and parallel to x-axis. So it will be just like this. Okay. What it actually means? It means if you change the value of x to whatever it would be, the value of y would remain same. How it would be? We can write this particular expression in two different variables like 0 times of x plus y is equals to 0. Is it possible to write this particular expression like this?
Yes, sir.
So whatever the value you will put in this particular expression for x, it gets multiplied with 0 and whole term becomes 0. So the value of y would remains the same, which is equals to 2. Okay. So we got a straight line passing through that particular coordinate and parallel to x-axis. Okay. So this is the first expression. Next is if y proportional to x and both have some linear power. If the exponential of both variables is linear, it means the equation is linear. What linear means? It means the graph of that particular equation would be a straight line. Now, a straight line may have different forms, like first, y is equals to sum m times of x, and the second, y is equals to sum mx plus c. Was what this term actually means, I'm giving you some relation. This m is called slope, and this c is called cut on y-axis. So in mathematical term, it is called y-intercept. What this slope actually means? It means tan theta, where theta is calculated with respect to positive x-axis. While going in anti-clockwise direction, it would be positive, but going in clockwise direction, it would be negative. So this particular theta is calculated from positive x-axis. So we have some sign related to this. While going in anti-clockwise direction, theta would be positive, and while going in clockwise direction, theta would be in negative. Is it clear?
Yes, sir.
So what we conclude for this particular expression, here we have C, which means cut on y-axis. But in this expression, there is no C. It means C would be 0 in this expression. It means this particular curve will cut y-axis at which point? This point. And the coordinate for which y is equals to 0 is nothing but origin. So we can call this particular expression of line will pass through origin. This will pass through origin. I'm giving you curve related to this. It will look like this. Or it may have expression like this, depending upon the value of slope. For the first red line, this is your positive x-axis. So inclination of this line from this point to this point, and then inclination of this particular green line would be from this point to this point. So this is your acute angle for which tan theta is positive, and this is your obtuse angle for which tan theta is negative. So it means slope of this particular red line would be positive and slope of this particular green line would be negative. You may take the slope of this green line from this point as well, like going along this direction. Whether this particular movement is in clockwise direction or anti-clockwise direction. Whether this movement
Clockwise.
is and clockwise, here we have taken which is negative. So from either way, from either from this part or from this part, we will define the slope of this particular green line to be negative. Is it clear to everyone?
Yes, sir.
Yes, sir.
Yes, sir.
So by simply knowing the equation of that particular relation, we would be able to define whether it will be a straight line, whether it will be passing through origin, or whether it will cut on y-axis at some different intercept. We can define using this particular information. Okay, just try to write.
Sir, done.
Okay. Hamza, have you written?
Yes, sir. Done.
Salman? Okay, done. Hiba?
Yes, sir. Done.
Good. So next expression is if y proportional to x squared. Here we have y has linear exponential and x has squared exponential. So it will call as parabolic curve. So what it actually means, even power of x, it means parabolical curve will be symmetry, or it will show symmetry about opposite coordinate, that is y-axis. How it looks like? It will be nothing but this way. And if I draw a line like this is called parabolic curve. Okay. It is somehow depicting symmetrical to the either axis or either direction. So this is your y-axis and this is your x-axis. So if I draw a vertical line from this, it will break this particular curve into perfectly identical half. So this curve like this is called parabola or parabolic curve. Similarly, if it be y squared proportional to x, it will show parabolic curve along x-axis and vice versa. So we just remember even power of any of the coordinate, it will define parabolic symmetry to the opposite axis. Okay. The next part is if there is no any constant term in this particular expression, it will always pass through origin. Suppose y is equals to some k times of x squared. Whether it has any constant part or not, here k is the coefficient of x squared. It is not as treated as constant. It would be like y is equals to kx squared plus c. This c would be treated as constant. It means this particular curve will pass through this particular point c above or below depending upon the sign of this particular c. Okay. The next part is the value of this particular k will define you in which direction this particular parabola will move. If k is in positive, then the parabola will be in upward direction. If k would be negative, it will look like this way. Okay. So if k is positive and c is equals to 0, it will pass through origin and it would be upward parabola. And if k is negative and c is 0, it will be downward parabola. Okay. Just remember this particular expression only. The next part is if you have x squared as well as y squared both. So what will we do? So we have two different expressions regarding this. The first expression is x squared over a squared plus y squared over b squared is equals to 1. So by the concept of this particular term, if there is an even power of x, it means there is a symmetrical curve along y-axis. But in this particular expression, here we have both x and y have even power. So what it actually means, symmetrically along both coordinates. Is it clear?
Yes, sir.
So symmetrical along both coordinates will define you like this. Draw a line and it will be symmetrically like this. Whether this particular curve is symmetrical to either of the axis or not.
Yes, sir.
So this particular curve is called ellipse. Since x has a coefficient a square, it means it will cut on x-axis at point A. Similarly, coefficient of dy is b, so it will cut y-axis at some coordinate b. Now, if I say if the coefficient a and b are equal, if a is equals to b is equals to r, this equation will look like x square plus y square is equals to r square. It means this particular curve will converges to this. What we call this particular geometrical figure, in which both of its coordinate, whether x coordinate or whether y coordinate, both are equal. What we call it? Just circle. Is it clear to everyone?
Yes, sir.
So just try to remember these equations. This is your elliptical equation and this is the equation of circle. Okay, we will use this particular expression in gravitation chapter. And there is one last section or one last part. If you have expression like this, y inversely proportional to x to the power n, n would be any number greater than or equal to 1. So the graph of this particular expression would be called rectangular hyperbola, and it will be like this and will go like this. Okay. On increasing any one coordinate, the other coordinate will decrease and vice versa. So this is called rectangular hyperbola. This particular curve has multiple applications in physics. Okay. Any doubt to anyone of you? Hiba?
No, sir.
Khalid? Any doubt?
Yes, sir, no doubt.
Good. Salman? Okay.
Done, sir.
Sir, done.
Hamza, done?
Yes, sir. Done.
Good. So the next part is to define the slope regarding given equation. So I'm giving you some tips to define slope, defining the slope of the given curve. If suppose if there is a line which is parallel to x-axis, there is a line which is along this. Slope means the tangent to that particular given curve. So if you draw a tangent over this particular line, it will just coincide over there. So the inclination of that particular tangent with respect to x-axis will define you the slope of the curve at the given instant. So to define the slope, just draw a tangent to the curve and draw inclination of tangent with x-axis. Okay. So the first expression, as this is a straight line which is parallel to x-axis itself. So if I draw a tangent, so it will just coincide over it. And the inclination of this particular line with respect to x-axis would be 0 or not? Whether this line is parallel to x-axis or not.
Yes, sir.
So if a line is parallel, then its inclination would be 0. So here I can define tan theta is equals to 0. Means slope is 0. Okay.
Yes, sir.
Next part. If I draw a tangent over this particular line, it will also just coincide over it. But if I draw inclination at different point, suppose at this point, it will give you some angle theta. Similarly, for this point, it will again give you some angle theta. And similarly for all of its points from origin to any one of them. Since this line and this line would be parallel and this line would be transversal, so this angle and this angle would be equal or not?
Yes, sir.
Yes, sir, they're equal.
Good. So for a straight line, the slope is always constant. Okay. So we can conclude from this, for a straight line, slope is always constant. Now, check this particular inclination with respect to x-axis, whether it is going towards anti-clockwise or whether it is going towards clockwise. So this is your positive x-axis and the inclination is going towards anti-clockwise. So what we can conclude about the slope, whether it would be positive or negative?
So positive.
Good. So tan theta would be positive. Is it clear to everyone?
Yes, sir.
Similarly, if I have drawn a line like this, this is your y-axis and this is your x-axis. what you can conclude about the slope of this particular line, whether the slope would be constant or varying. I have just explained for a straight line, slope is always constant. Now define whether slope is positive or negative. Heba,
Sir, it is negative.
good. So just draw a line with respect to, or to define your positive x-axis and make its inclination from this particular line. It is going along clockwise direction, so it would be negative. So it means tan theta here is negative. Okay, any doubt?
No, sir.
No, sir.
Just write it down. Salman, any doubt? Good. I will ask this all for concept in further studies.
Sir, done.
Sir, done.
Heba, have written.
Yes, sir.
Salman, okay. The next is to define. Suppose there is a curve like this. This is your y-axis and this is your x-axis. If I ask you to define whether the slope is constant for this particular curve or not, so just draw a tangent from this point, again a later tangent to this point, and so on. Now, to define the inclination of that particular tangent, draw a horizontal line at the point of contact. Similarly, for this point, draw a horizontal line at the point of contact. Whether the inclination of these tangent with respect to x-axis is positive or negative.
Positive.
Good. It is going along anti-clockwise direction and is also going along anti-clockwise direction. So at this instant, inclination is, let's say, theta 1. At this inclination, let's say inclination is theta 2. Okay. Whether theta 1 and theta 2 are equal or not. Whether theta 1 and theta 2 are equal or not.
No, sir.
Which one is greater?
Theta 1.
I think theta 1 is looking smaller as compared to theta 2. It has
Yes, sir.
wide separation between them. Okay, so from this we can conclude theta 1 is smaller with respect to theta 2. And tan theta, similarly as theta moves or theta goes, the tan theta also changes. So tan theta 1 would be smaller as compared to tan theta 2. So we can call this particular graph as increasing slope. Okay. Increasing slope. Slope is not constant. It is increasing with some rate. Is it clear?
Yes, sir.
Salman, any doubt? Okay. The next thing is, if we define this particular curve like this, so just draw a tangent over different instant. Suppose at this particular instant of time, and then later on at this particular instant, like this. So if you draw a horizontal at the point of contact at this point, similarly, if I draw horizontal at this point, this would be again in anti-clockwise direction. This would be again in anti-clockwise direction. Here theta1 is, and there theta2 is. Both theta is calculated in anti-clockwise direction, so both are positive. So here theta1 is also positive and theta2 is also positive. But which one is the larger?
So theta1.
Good. So we can say slope of this particular curve is decreasing. So theta1 is greater than theta2. It means tan theta1 is greater than tan theta2, or we can simply say decreasing slope. Khalid, any doubt?
No, sir.
Salman? Okay. Just try this.
Sir, done.
Sir, done.
Good. Hamza?
Yes, sir. Done.
Salman? Done? Okay. So we have just finished this whole topic. I'm giving you one more problem regarding this particular calculation of slope. Try to solve on its own and show me your answer in our next class. Suppose if you have a curve,
Sir, what to do again?
I'm giving you. If you have a curve like this, and if you have a curve like this, try to define the slope of these curves, whether the slope is increasing or decreasing, as we have done in the last part. Try to find the slope of curve and define whether the slope is increasing or decreasing. Okay? Define the slope, whether it is positive or negative, whether it is positive or negative, and also define slope is increasing or decreasing. This is your homework. Okay, Hamza?
Yes, sir.
Salman, any doubt? Hiba?
No, sir.
Khalid? Okay.
Yes, sir, done.
Have you all written?
Yes, sir.